I feel like I'm losing my mind. Is everybody in the world blind? Please, Lord, give me a sign.
Welcome back to the channel, guys. And I guess you saw from reading the description, we're going to be putting halo LED lights in the truck today. Now, these are actually, some people call them halo, some people call them angel eyes, and I'll show you when we go to the table. But I want to give a shout out to my little nephew. He always watches the channel. He told me the other day at Thanksgiving dinner that he was going to go watch DT Performance. So Luke, thank you, buddy, for watching. And for those of you coming back, thank you for stopping by and watching also. Let's go over to the table, check out what we're going to use today. I'm going to talk about how we're going to wire them up, and we'll get started. Okay, guys, here's what we're going to be using. Let's look at the lights first. These are the Octane Lighting 7x6. Some people call them halo, but some people call them angel eyes because the LEDs actually light up just on the sides of the light. But I'm going to call them halos from here on out. They do have the H4 9003 light bulb in them. They are a plug and play for the S10, and also you can change these out to LEDs. LED bulbs will fit right in here and they're plug and play. The way I'm going to wire my lights is I want these to come on when the parking lights are on and go off when I turn the headlight on. Some states have different laws and regulations on running lights down the road. Now these are red, and you can get blue and white and green, but I chose red because it matches the color of the truck. Now, some states have different regulations on running red lights that face traffic. Some people can get away with it and they say, well, they don't bother me here, but I don't want any kind of problem. So when I turn my headlights on, I want my lights to cut off these LEDs. And then when I'm at a car show or parking at the racetrack or whatever, and I turn my parking lights on, I just want these red lights with my marker lights on. So those are the lights. I've got relays we're going to use to make that all work, and I'm going to show you the schematic. But let's look at the parts. I'm going to have some 1/4 inch convoluted tubing. I have two different kinds of relays that I was going to show you guys. You can use whichever kind you like. What I have are these relays here, and these are not weatherproof. As you can see, they're open. You can stack them together, and these just plug in the top, and they have little tabs that snap in that you can bolt them to the fender well or whatever you'd like. But I am actually going to be using these weather-tight relays. You can see it has a seal on the bottom. It also has a seal around the edge with the shield on the relay. Again, all these parts, there'll be links to the description down below. I'm going to have some spade connectors that are insulated. I'm going to make a bracket. You'll need a T15 Torx bit to get your grill out. I've got these countersunk bolts to put my bracket on. Going to need some zip straps. I'm going to be using 14 gauge wire. I've never used these before, so I bought these. These are automatic self strippers. I've always used these. Some heat shrink tubing, my soldering iron, and then as you can see, I've had my meter along with a battery up here, and I've been doing some testing. So this is probably going to be a longer video than what I usually put out, because I'm going to talk about relays. I'm going to talk about why we use relays and how I'm going to activate them, how I'm going to make these lights turn on and off. These angel eyes or these halos turn on and off when I turn my bright and dim lights on, or my headlights on. So I will put markers in the video. So if you already know about relays, you already know about how to make that work, great. You can fast forward, get to the part where we put the lights in the truck. I'll do some before pictures showing you how the lights, the factory halogens, shine up against the front of my shop with the lights off at night. And then when I get these installed, we'll also do an after and put them side by side and let you guys be the judge. I'm also going to talk about why I chose, these are reflective, and you can see the reflectors in there, over the projector style. I had my reasons, and I'll talk to you that. I'm going to cut you off, carry you over here to the whiteboard. Let's talk about the amp draw on the lights, why I chose to use relays, why I chose reflectors over projectors, and we'll get on with the video. Okay guys, what I want to talk to you about is projector versus reflector. And these are reflector lights, what I purchased, and I'll tell you why. But let's walk through how a projector compares to a reflector. So in a reflector light, which is what I have, you have your light, you have your bulb, and in an S10, it's a 2-filament bulb, meaning that it has 2 different filaments. If you've ever looked at a bulb, you can see the filaments in there. So what that means is when you turn on your low beams, you have a positive 12-volt source feeding that bulb, turning this on. This one is not on. When you hit your dimmer switch, you turn the low beams off and you go to high beams. And the way that works in this particular instance is in a reflector, the light comes off of this reflective surface, it goes out, and projects the beam out in front of the truck. When you do the high beams, it's the same thing. You turn off the lows, you turn on the highs, you get a different filament projecting the light, making a brighter light or at a different angle coming out of the truck. And it allows you to see farther going down the road. Now in a projector style, you have your housing, you have your bulb, and you have, if you've ever looked at a projector, most of the time it looks like it's got a round tube inside of it. And in the bottom of that tube, there's a shutter, kind of like on a camera. If you've ever looked in the front of a camera, when you take a picture, you'll see that shutter open and close. So in a projector style light, you have your beam, and when you turn it on, you have this shutter that sits right in the lower half of that bulb. So when you turn your low beams on, or well, when you turn the lights on in general, you have the light coming out of the bulb, going out in front of the truck. Now when you flip to high beams, what happens is this shutter moves out of the way and allows more light to come out in front of the truck. And that's how a projector versus reflector style beam works, or style light bulb works, or headlight. The reason I chose the reflector, one, halogen beams have been reflective for years, up until they came out with all this new LED technology and all these projector style lights. Halogen is what we've known for years. So in my opinion, going to a reflector style H4 9003 bulb is going to be much brighter than the old technology for minimal price. And that's another thing. I think I get the best bang for my buck going to a reflector style with an H4 9003 bulb over the projector. Plus you have moving parts in some of your projector style lights. This is another part that has to move. These are typically a little bit more money. And for, like I said, for the bang for the buck, I think the projector style is the way I want to go. Now, I do know that they make LEDs for both. They have LED lights for both styles of lights. And I may make another video showing the difference in the H4 9003 bulb versus the LED. But for now, at the end of this video, what I'm going to do is I'm going to show you the difference in the halogen stock light bulbs, the Sylvanias is what I have, versus the H4 9003 bulbs that we're going to put in with these Octane lights. And I'll put those side by side, and if I do another video with LEDs, we'll wind back and look back at the H4 9003 versus the LED and let you guys be the judge. So next thing we're going to do is talk about relays and how I'm going to make my marker lights turn on the halos and off with the headlights. And we'll talk about relays and how they work, why we use them, things like that. Again, there's markers in this video if you want to skip to the before and after, so you can get to the good part of the video and say, hey, I like those lights more than I do my halogens. Feel free to do that right now. But what I'm going to do is I'm going to set up and get the grill out of the truck. We're going to start putting the headlights in, get them wired up, and do a before and after, and show you guys how they work. So thanks for sticking around this long if you're watching all the way through the video. If not, fast forward to the end and see the before and after. Now, for those of you that may be new to wiring, I've never wired a relay before. I'm going to show you. You can see the schematic over here of how a relay is wired. This is the base and this is the actual relay. And I've got some notes here for you guys. I'm going to draw the schematic later in this video of how I wire my lights. So in case you want to wire yours to turn the halos off when the headlights come on, you can do the same. If not, you can just wire them into a switch and turn them on and off all the time if that's what you choose. But why do we use relays? A relay is nothing more than a switch. And if you look at this schematic, I'm going to draw this for you. This relay has a coil in it, and this is the actual schematic for that relay. You have 85 and 86, that is the wires that activate the coil. You have pin 30, it goes to 87A, and then 87. Now, this is magnetically connected. When you energize this coil with positive and negative, this will magnetically shift this lever arm up to this post. So let's say, for example, we've got positive battery voltage here. We've got this going out to ground. This goes up to a light. You've got the ground on your light. And then you have this is connected to power. So what happens is you could tie this over to a switch of some kind, or in our case we're going to use the marker light signal. When I turn my marker lights on, it's going to trip this relay and turn my halos on. But the reason we use relays is because this part of the relay right here, let me draw it in a different color. This part of the relay right here, the coil part, uses very minimal amps. And when I measured the amp load on these relays up here, my relay, the coil used 0.5 milliamps. Or actually 1.15 amps. That's actually 150 milliamps. It takes 1,000 milliamps to equal 1 amp. So the coil on this is only drawing 15.15 amps or 150 milliamps. Now, that's nothing. That means you can use little wire, smaller gauge wire, which is cheaper, to activate this coil. You can use different things. That's why you can add these to circuits without having to upgrade wiring a lot of times, because this pulls really nothing. Then we go to the top part of the relay. The top part of this relay, this is where your relays are typically measured. So if you go to the parts store and you buy a 30 amp relay or a 40 amp relay, this is the part that does all the work. So when I flip this switch down here and I pick up positive 12 volts, I make this switch, it activates this coil, and it's a magnet. It's a coil of wire that magnetizes. It shifts this lever arm up. This lever arm now goes to here, and you can see my positive power right here is also connected to battery. Now this can make this path to the circuit and turn this light on. These relays can be used for all kinds of different activations. It could be a nitrous solenoid. Nitrous solenoids, if they pull a large amount of amps, or you have several switches or different devices, you can use a switch that pulls minimal amps, remember 150 milliamps, and you can pull 30 amps. Now you have to use larger gauge wire, and you'll have to research what size wire you're going to use. Most of the time 10 gauge is big enough to pull something big, but on this circuit we're not going to use that kind of wire. I'm going to show you why. So that's a relay and how it works. Now I'm going to draw the schematic and walk you through how I'm going to make my lights work. The halos come on with the marker lights and go off with the headlights. So that's the next part of the video, and then we'll get into the installation, and then I'm going to show you guys the before and after. So stay tuned. Okay guys, rather than just draw a schematic, put it up here and walk through it, I actually want to draw out the components and show you, walk you through each step on how I'm going to wire my lights up. Again, I'm going to wire mine up so when I turn my marker lights on, my halos come on. So the first thing we're going to look at is you've got your marker light. And it has, in the harness, it has ground going to it. From the switch, this is your switch inside the cab that turns your lights on. This has 12 volts going to it. That's from the switch. I'll label this. It's your marker light. So when you push the switch in the cab, 12 volts goes out to the marker light. The marker light has ground also. The marker light comes on. So what we're going to do is we're going to utilize that power. And I told you you could use, I'm going to use 2 relays. Now for you guys that do electrical work, I could use 1 relay and a diode. I'm not going to get into that. I had rather use 2 relays just for the simplicity of troubleshooting, not having to wire diodes into the harness, things like that. So we'll keep it simple. So inside of this relay, you've got the coil. These are the wires coming off the coil. And I've got the schematic symbols over here for you guys. This is the base of the relay. And this relay, those pins plug in. And you'll see it when you open them up. So you've got 85, 86. Inside the relay, you've got pin 30. And a lot of electrical guys will call this common. This is your common, 87A. And it's common, it's called common because it shares the connection between these two. This is normally closed, meaning when this relay does not have any power, these contacts are touching. Now when it opens, when you put power on it, it flips the switch up here to 87, and we'll look at that in just a second. Let me get this drawn out for you. Pin 30, 87A, 87. We're going to have our halos up here. You've got ground and power on both sides of your halos because it has 4 lights total. And again, some people call them angel eyes. I'm just calling them halos, but we'll draw them in here. They call them angel eyes. Some people call them halo lights. Just whatever you want to call them. And then you have your 12 volt power red wire coming out for each one. And that's the way your lights are going to look. Now again, these are going to direct plug and play to the connection on your headlight switch in your truck. And I drew that out for you here. That's what it looks like. And the low beams are the tan wire. The high beams are the green wire on my S10. Now this would work for any type of truck if you know which wires are switched. And this would be ground. Now, keep in mind that all these grounds, we're going to say these 85s are your ground wires. All these grounds are common. They're either going back to the battery through the harness or they're screwed to the metal in the frame or on the radiator support or something like that. So how I'm going to make mine work is I'm going to tie into the power wire on the marker light. I'm going to bring it down, tie it to pin 30. I'm going to tie pin 87 to pin 30 on the other relay. And we'll call this the low beam relay, and we'll call this the high beam relay. And I'll mark them in my truck with high and low so I know which one's which. So now, I will come up, tie to all of my red wires on my halo lights. I don't want to confuse you. I don't want that to touch. I'll do it right back in the same spot, didn't I? So now, when I flip the switch in the cab, put 12 volts across this circuit, you can see it's going to come down, it's going to light up my marker light. It's going to send power through pin 30 to 87, from 87 to 30, from 30 to 87 and up to my power. And all these are grounded, and my halos, these red lights here, are going to come on. Now what's going to deactivate those halos is I'm going to tie into my lighting harness, my headlight harness. I'm going to come from my low beams to my low beam relay and tie to the coil. On the low beam relay, I'm going to tie from my high beam relay or high beam harness on my plug for my lights, my headlights, to my coil. So now what happens is when I turn my low beams on, this switch, this coil, is going to get magnetized, and it's going to move this lever, this contact, it's going to move it up. So now you can see I have no connection here. So no power is flowing to my halos. So when I turn my high beams on, these go off. Same thing if I'm looking at my high beams. When I activate high beams, this is going to open. And there's going to be no power here. The thing is on a S10 is when the low beam has power, the high beam does not. When you click your dimmer switch and flip, go to high beams, the low beam does not have power and the high beams do. So these are not powered at the same time. So that's what makes this work. That's why you have to have two relays. So that's how I am going to make my halos turn off when the headlights are on. Now, keep in mind, I designed this circuit to fail safe. And what I mean by fail safe is if any of these wires break or I don't get a good connection, my headlights still work because I'm still plugged into my main harness. All I'm doing is tying into this harness, and as long as that connection doesn't fail, my headlights will still work. And I'm not going to cut the wires, I'm going to tie into them. So I'm not worried about if any of this right here fails, causing my headlights to go off when I'm driving at night. The only thing that will stop working will be my halos. My headlights will still continue to work. Now, I told you earlier that I'm going to use 14 gauge wire on all my connections. And the reason I'm doing that, I'm not going to put, most of the time you would want fused power coming into your relay. But the reason I'm not doing that is you saw my battery on the table. Each one of these lights here only draws 0.07 amps. So if I total all those up, I get 0.28 amps. That's all that those 4 halos pull. Now, again, remember, it takes 1,000 milliamps to equal 1 amp. Now, I'll put this in perspective. So 0.28 amps is 280 milliamps. It's not even a half of an amp. So these 4 halos here pull less than a half of an amp. That's why I'm not going to put a fuse on it. I don't feel that there's a need for a fuse. Now your relay coils, the reason I'm not going to fuse anything here, these relay coils only pull 0.15 amps or 150 milliamps. So they only pull less than just a little over 1/10 of an amp. So even if I totaled all of this up together, it pulls less than a half an amp. So that's why I'm not worried about putting fuses and doing all that. Now, if it got on up, you know, into a couple of amps, I would probably put fuses on there. But that's how I'm going to wire it. I'll back off here, let you take a picture of that. But I wanted to walk you through it rather than just draw it up here so that you would understand how these relays, when you put power on the coil, how they activate and break switches and how and why we use them. You can also use these for grounds. I mean, you could have power sitting here and put the ground to it. There's multiple ways to use relays, and I hope this helps you out. So stay tuned for the next section. We're going to wire the lights in, and I'm going to show you some before and after and let you decide if this is the route you would like to take with these headlights. Hey guys, just a quick update on the install. As you can see, the light's going in. It does fit and plug in. It is plug and play. The only thing I seen is when I was putting my wires through the headlight bucket. Now I've modified this bucket. This is the back side. I cut me a little notch here because on one that's not been modified, this bucket comes right around the bottom of this rubber seal right here. You've still got plenty of room to hold this seal in. That's not my concern. My concern was when I put it in the one I just showed you on the passenger side, these wires were smashed up against this rubber on the edge of this metal, and I was afraid these wires moving around the edge of that metal would cut into this. So I made me a little notch right here, and I'll probably take me a little piece of tubing and line, like rubber tubing, and line the bottom of this notch so that these wires aren't rubbing back and forth on this metal. So that's one thing I wanted to show you, and I I did take an amp load from these are Sylvania H6054s, and on low beams they draw 2.56 amps. On high beams they draw 4.65 amps. So on low beams you're looking at about 5 amps total for both headlights, or you're looking at about 9.3 amps on high beams. On your halos, or on these Octane lights here, they draw on high 4.87 amps for each light, and 4.37 on low beams. And I did a little power conversion real quick. How many watts? Power equals amps times volts. I worked all that out. They are 54 watt light bulbs, these halogens, and so are the Octane lights. They're both 55 watts. So I tested it, confirmed it with a meter. So all good there. Just keep in mind, when you put your wires in, you might want to notch out like I did so they don't rub. And also my screws for my trim, show you these right here. These screws were really rusted, so you might want to get you some. I had some stainless screws that I put in there. You might want to go to the hardware store and pick up some stainless ones. These were pretty rusted. So I just wanted to pause the video for a second, show you, or cut into the video, and I'm going to run this along the bottom just like I did the other one and get it in. So let me get this done. I'll show you the final install. We'll test the halos with the relays I wired up and see if everything works like I said it would. Stay tuned. Okay guys, we got the harness put in, we've got the relays installed, and now is the moment of truth. We're going to turn the marker lights on, see if the halos come on. We'll turn the headlights on and see if the halos go off, and check out our wiring. Perfect. The halos come on. Notice how our marker lights, our factory marker lights are on. Now let's turn the headlights on. Our headlights are on. Notice how our halos went off, but we still retain our factory marker lights. Now let's hit the dimmer switch. We go to high beams, our halos remain off, and if I flip the headlights off, the halos come back on. So everything works as it should. My marker lights continue to stay on with the headlights on, but the halos go off with the headlights, and everything works as it should. So next up, we're going to do before and after from 25 feet away and 50 feet away, and let you guys see what a halogen versus an H4 9003 bulb looks like. Okay guys, here's what we did. We compared the lights at 25 feet on low beams, 50 feet on low beams, and 50 feet on high beams. We did not do a 50 feet on low beams. You can see with the halogens on the left and the Octane H4s on the right, at 25 feet on low beams, the octanes appear a lot brighter than the halogens, with the halogens having a lot more spread out light pattern. When we get over to the 50 feet on low beams, the halogens on the left, the octanes on the right, the halogens have a more concentrated beam, whereas the Octane H4 have a more dispersed beam. Now, moving to 50 feet on high beams, again with halogens on the left and octanes on the right, the halogens appear to be way brighter than the octanes. The octanes have a scattered looking light pattern, but you know, I don't think the photos actually show an accurate depiction of what I saw. But I'm going to let you guys decide. So let me know what you think in the comments below on what you think is the better light pattern. Well guys, that's the end of the video. Did you like the before and after? Is it something you might be interested in doing? If got any comments, got any questions about how the relays work or how they're wired, don't hesitate to reach out to me below in the comments. I'll be glad to walk you guys through the wiring process and how I got it to work. If you like this video, hit that like button. As always, comment below. And if you're not a subscriber and you like this content, this kind of stuff right here, we're going to be doing a lot more stuff to the S10. hit that subscribe button right now before you leave. Don't forget, that way you can be updated with any new content that I'll load in the future. Thanks again for stopping by. For all you guys that are new to the channel, all you guys that are coming back as subscribers, thank you for coming back, and thanks again to my little nephew Luke for always tuning in and supporting DT Performance. Thanks guys, and we'll see you in the next episode.